All right, good morning. That was like 3 people. Everybody else is like already asleep. That's okay. I drove in from Indianapolis yesterday, so like I'm probably like half brain dead, so forgive me. All right, so my name is Jeremiah Robertson. I work for the Air Force Nuclear Weapons Center at Kirtland Air Force Base in New Mexico. I am a smart scholar, I'm gonna go back to school here in the fall, and I kind of work and go to school kind of back and forth. And I'll be starting at MIT starting in the fall. But what I want to share with you is some of the research I did while I was at Georgia Tech as a bachelor student in aerospace, tornado destruction using high power microwaves. So just to start off, how many people have either been affected or know someone who's been affected by a tornado? Some way, some fashion? Okay, that's not a whole lot of hands. Okay, so I'm from the Midwest, I'm from Missouri, and so, if I ask there, everybody there is gonna be raising their hand. The reason I ask is to kind of give it a personal touch whenever I talk about it. So according to the National Weather Service, 70% of Americans are affected, either have been affected, family, friends have been affected by a tornado some way or another. And so I want to start by saying why tornadoes? So out of all these natural disasters that exist, hurricanes, wildfires, why focus on tornadoes? And there's kind of two big reasons. One of them is because tornadoes cause the most destruction. Economically, we were talking about billions of dollars of damage every single year due to tornadoes alone, which is tenfold more than any of these other disasters that you'll find up here. And the second reason is because of the solution that we're able to use on tornadoes. It's economically feasible, and it'll be efficient in terms of taking them out. So my personal experience. So I told you I grew up in Missouri. So this is the high school that was in the Joplin, Missouri tornado back in 2011. And come on. Maybe I can do it up here. Is it going? It's still not going. Okay. No? Okay, well that's okay. But basically, so this is a video, and all you'll see is that an EF5 tornado is gonna go through and just crush this entire gymnasium. So why is that significant is that so you'll see it's causing, thousands of dollars worth of damage, but it does it within like 10 seconds. The damage that is done in the amount of time is huge. And so taking out a natural disaster of this proportion would be a huge benefit to society. And so also, if you think that this is bad, it only gets worse. So Miss Miller this morning talked about thinking like an adversary. And so I work for a red team for the Nuke Weapons Center. And so we think like the adversary all the time in terms of what their capabilities are. So thinking what an adversary could do, imagine an adversary artificially creating a tornado and using it. New York City, Los Angeles, places where you wouldn't even normally see a tornado, actually artificially creating one and having it show up in a city, and imagine those cities getting the damage instead of, small town Missouri. You can imagine, even more than billions of dollars worth of damage. You can almost get into the trillions at that point, depending on how many cities you're trying to hit. And then, not only that, to take it even one step further, let's say you add something to the tornado. This is from a movie, but imagine you could actually, you add in fire into the tornado, because all a tornado is your classic mixing problem. And so you could add in, weapons. It could be biological or nuclear weapons, fire, deadly chemicals. The possibilities are endless. And so, all of that being said, so how do you actually take out tornadoes? So Nikola Tesla is actually the first person to think about this sort of problem. And what Nikola Tesla did was he thought about using high power explosives. And so that would work, right? You just need some sort of high force impact in order to take it out. And the demonstration I would like to use, if we had like an Elmo, but just imagine like a soup can, and imagine there's water inside of it and you spin the water around, right? It's a tiny tornado inside of a little soup can. But then if you take that spoon and you tap the outside of that soup can, you provide a force to the outside of it, you're gonna stop the spinning, right? Because you're impacting it with a force. So that's the idea. You impact it with some sort of force, and that stops the rotation. And so, explosives would do it. However, it doesn't make a good storyline to say that the government sent a B-52 with B-61 bombs on it to go blow up a tornado to stop it in the middle of the United States, right? That's not going to work. You would actually probably cause more damage than the tornado would itself. Other ways of providing that force, things like giant hoses. I mean, people have thought of, the most random, like out there ideas to try to do something like this. And so now I want to share how a tornado is actually formed and why high-powered microwaves are the best solution for it. So well, that one's okay. I'm just struggling today. Let's see. It's still not going to play. Oh, man. Okay. Maybe I'm pressing buttons or something. Okay, that's okay. But so how a tornado forms is that you have a high temperature and a low temperature system. So as everybody know, hot air rises and cold air sinks. That's right, because of the density. And so because of that, so you have a thunderstorm layer at the top, right? You have all these clouds, a dense thunderstorm. That's holding the hot air in, right? So your hot air is up here, the thunderstorm's holding it in. You have the cold air, which is at the bottom, which is being held up by the ground. And so hot air, cold air, they're both inside of the system, and you combine 150 mile per hour winds, that gives you the circulation for your mixing, and that's what causes your vortex, which gives you your tornado. So that's what actually causes it. And so the significant part of that is so that's what creates your actual supercell vortex, and then it touches down on the ground, and the reason it does that is because that's what makes it stable. And that's the key. A tornado is only stable if it actually touches down on the ground and stays on the ground. And what happens is you have what's called a rear flank downshaft, or RFD. And whenever that RFD either becomes hotter on the ground or cooler in the air is whenever your tornado actually dissipates, after 10, 15 minutes. And so the reason that's key is that if we get that tornado off the ground, it'll dissipate on its own. That is how you stop a tornado. You destabilize it by lifting it off of the ground so it's no longer stable, and the vortex will actually dissipate. And so high power microwaves, and how is that significant? So high power microwaves will not only provide the pressure force that we need, right? Just like the spoon, it'll provide that high pressure force. It'll also heat that air that's on the bottom, right? So if we heat the air on the bottom, it's going to rise. And then as it rises, your tornado is lifted off the ground, it becomes unstable, it dissipates. So you get a twofold with high power microwaves. So this video, it's not gonna play either, that's okay. But so this video, what you would see, so this is a 15-watt fluorescent light bulb, typical any day light bulb. We took a 700-watt microwave, just typical microwave as well, and whenever you add waveguides to the microwave, so waveguides just allows you to shoot all of those microwaves in one direction, right? Instead of like a passive microwaves everywhere, you're actually you can aim them. Whenever you aim those microwaves at a 15-watt fluorescent light bulb, from about 2 feet away, you can light it up. So I know it's hard to see here, but the microwave is like somewhere like back here, and you can actually power this light bulb using those microwaves. So the reason that's significant is imagine that the amount of power goes up to 100,000 watts or even 1,000,000 watts, which I know is a ridiculous amount of power, right? I get that. And it's going to take a lot of power to take out like actual large-sized tornadoes. But the implications are that you can, from 2 miles away, using the proportional amount of power on a proportional natural disaster like a tornado, you would actually be able to hit it, right? That's the significance. So you don't need to be like right up, shooting microwaves right next to a tornado. You can actually, from 2 miles away, be able to use high power microwaves to take these things out. So this is unfortunate that this one won't play because this is the coolest one. But so we actually did an experiment in Kansas. So this was probably 3 years ago now. We went to Thayer, Kansas, which probably nobody knows that even exists. But we actually tracked this tornado. So this is very small, just EF1, barely can do damage, very small tornado. But so what we did is we built 15 of these microwave devices, right? So not just the one with the light bulb, but actually 15 of them, all using waveguides. We tracked this tornado, set up the microwaves around this area, and actually shot them at the bottom base of the tornado. And what you would see is that, the temperature is going to be very, very hot down here, like definitely don't want to go inside, but that this tornado will actually begin to dissipate, right? It gets lifted off the ground, it becomes unstable and starts to lift. So the question, does it work in real life? Yes, it would work. So we don't have the power yet for larger tornadoes, but that'll come as technology progresses. Okay, so how do we experiment without potentially putting people in danger and actually like going and testing on real life tornadoes? So caution, don't try this at home. We actually use very cheap parts instead of parts we should have been using, right? So we should have had a vortex blower, which could be thousands of dollars. Instead, we used a $5 Walmart fan. We should have been using IR lamps. We used a heater from the Walmart clearance section. We should have been using a radiator and liquid droplets. Instead, we used another different heater and literally just took Dixie cups and poked holes in the bottom and put water in it. And so the reason I like to share this slide is because I hear people all the time, I don't have the money for this. I don't have the resources for this. I need more graduate students for this. All of these things. You can do experiments with very simple materials, right? You don't need millions of dollars. I don't need an entire research team to do things like this. It takes a few people that are inspired and motivated to want to work on something to do it. And so, this whole setup right here is, $200 easy, right? And then, but does it actually give us what we want? And the answer is yes, it does. So it's called Spectral Particle Velocimetry, SPV. And so what that does is you throw in particles as your simulation is running, and you can measure the velocity of those particles, what direction they're going, what forces are impacting them, things like that. And so looking at the magnitude and the vorticity of the particles as they go inside of the simulation is what we would expect out of your average F2 tornado. And so think of it, it's like a wind tunnel, right? So a wind tunnel, you're not testing a real airplane inside of the tunnel. You're testing what is a model of that airplane. This is the same idea. We're testing a model of the tornado inside of a simulated environment. Okay, so all of that to say, why does this matter? So this is from The Day After Tomorrow. It's a corny movie, but I love it. But so this is, New York City. They've got 6 tornadoes coming in, thunderstorms, all of this stuff is going on. And I know it was science fiction, but I think that the truth is, you give it 10 years from now, something like this could actually happen, right? This isn't science fiction anymore. This is actually real. People are controlling and affecting the weather in different ways. And I think it's time, we start actually taking it seriously so that we avoid something like this from happening in the future. We're talking about saving billions of dollars worth of damage, over 5,000 homes every year, and even, potentially hundreds of lives. And then, my aunt and uncle were affected. Their house was inside of a tornado, got damaged. And so, personally for me, that's why I'm trying to take on this endeavor. But that's all I have. Thank you very much.